Alright, so I think this is recording. Let's take a look and solve this exponential equation. We are able to rewrite these with the same base. We do not have to use what they refer to as logarithms that are the inverse of exponential functions. We'll see that in a later subskill. So I'm going to rewrite everything with a base of 6. So this numerator already has a base of 6, 6 squared. And 216, we've seen that that's 6 to the third power in previous videos. And 36 is 6 squared. Alright, so when I have a power to a power, I multiply the exponents together. So I have 6 squared divided by 6. Well, 3 times 2n is 6n. I could do one of two things here. I could cancel these 6 squared from each side, but I won't do that because that could confuse people. Let's since we have division here, we've got this exponent of 2 minus this exponent 6n. It's the exponent in the numerator minus the exponent in the denominator. And now, since this is a one-to-one function, if the numbers are the same and the bases are the same, the exponents must be the same. So this is a two-step equation. Subtract 2 from each side and divide by 6n. But as soon as you subtract 2, you see that n has to be 0. Because even 0 divided by negative, it's okay to have a 0 in the numerator, you just can't have it in the denominator. So this, if you go back and look at that original equation, the 216 raised to the 2n power, 2 times 0 is 0, 2 to the 16, 216 raised to the 0 power is 1, and 6 squared is equal to 36. So, I mean, some people, I suppose, could have seen that in the very beginning by inspection, but I just wasn't paying that close attention to the original equation. Alright, so let's do the next one. The 64 and 16 could be rewritten with a base of 4, but 32 can't. So we're going to have to rewrite all these with the base of 2. Alright, so 2 raised to the 6th power is 64. Times 2 to the 4th power is 216. And 2 to the 5th power is 32. So over here I have a power to a power, so I'll multiply these exponents. So I've got to distribute the 6th to both terms. Try not to make any silly sign errors or multiplication errors as I do that. This binomial gets, each term gets multiplied by 4. And since I'm multiplying two values that have the same base, I add the exponents. Negative 12a plus 8a is negative 4a. And 18 plus 4 is 22. Alright, so if I haven't made a mistake, we've got the fact that exponential functions are one-to-one functions. If the numbers are the same and the bases are the same, the exponents have to be the same. So this negative 4a plus 22 is just an ugly way to write the number 5. So in two steps we have our solution. We subtract 22 from each side and divide by negative 4. 5 minus 22 is at a negative 17. Divided by a negative 4, and the negatives cancel, and we just have 17 over 4. Exponential functions, I don't have to worry about extraneous solutions, so I claim that's our answer. Let's do the next one. Alright. Let's rewrite everybody with a base of 6. 216 is 6 to the third power. 36 is 6 squared. And this is 6 to the third power. When you have a power to a power, you multiply these exponents. So we've got negative 6m here. We distribute this 2 through that binomial. We got 2m plus 2. We're multiplying these two exponential functions have the same base. So by properties of exponents, we add these exponents. Negative 6m plus 2m is a negative 4m. If for an exponential equation, if the numbers are the same and the bases are the same, the exponents have to be the same. And this is a two-step equation. Subtract 2 from both sides and divide by negative 4. If 3 minus 2 is 1, and divided by negative 4, and we have our answer. Alright, so let's take a look at this one. Let's rewrite these bases as a base of 6 raised to some power. So 216, I think, is 6 to the third power. Uh, 36, I think you can see it in one step, is 6 raised to the negative 2 power. A negative exponent never makes your answer negative. It just changes the base, the location of that base within a fraction. We have a power to a power, so we multiply these exponents. Alright, so here multiplication and the base is the same, so we add the exponents. And the fact that exponential functions are one-to-one functions, if the numbers are the same and the base is the same, then we can set these exponents equal to each other. Subtract 6r from both sides, and you see that r is equal to 0. Alright, so I hope that helps, and I'll talk to you later.